Hi, everyone. Welcome to the session, Chrome Apps State of the Nation. My name is Erik Kay. I'm Engineering Director at Google. Just a quick reminder up front before we dive in. We're really interested in getting your feedback on how each of these talks are going. You can use either the I/O app to rate the session and give us feedback, or use the QR code in the back to do a rating. So first off, just what is this talk all about? It's about Chrome packaged apps. This is the way to build native quality applications using the Chrome runtime. Let's see. So how many of you were here at last year's talk when we first gave a preview for what Chrome packaged apps are all about? All right, good. Thanks for coming back. For the rest of you, let me give you a little bit of an overview of what Chrome packaged apps are. So the idea here is that people want to be able to build native quality desktop applications using web technology, using the web technology stack, HTML, JavaScript, CSS. They would like, though, at the same time, to not give up all the capabilities they're used to. Access to the hardware, access to the operating system. They'd like to look and act, behave as peers for the desktop counterparts. And so that's what we've built with Chrome packaged apps. And I'm going to talk in a lot more detail about what each of these aspects are, but that's sort of the idea in a nutshell. Now last year, as I said, we gave a sneak peek of where we were at with packaged apps. Showed you how these apps were immersive, how they ran outside of the browser and allowed for customizable UI, full control over all the windows, how they interacted with the hardware and operating system capabilities, and how they were offline enabled by default. So after that, we put it available behind a flag over the summer. We started shipping a few default packaged apps in Chrome OS this fall. We've had a few hackathons. I hope a few of you made it to that. If not, there's more hackathons coming. Keep an eye out for those in your local area. We had a developer preview turned on in February, so you could start uploading your package apps to the store. And just the other week, we enabled our consumer preview, which means anyone at the dev channel can now go to the web store and see all of the package apps that have been uploaded there. And in our next release, Chrome 29, we're looking to have a full consumer launch. So let me dive in a little bit about each of the properties that we have for Chrome packaged apps. So first off, I said they're immersive. So what does that mean exactly? Well, it could mean a couple of different things. For example, it could mean something like this YouTube app. Now, this is the full experience that you see maybe on your TV or on the PlayStation, but all custom UI, full screen, immersive, so nothing in the way. But immersive doesn't just have to mean that. It doesn't have to mean full screen. It might mean that it's just part of the operating system. It's taking advantage of different features of the operating system. So for example, this presentation that I've got going up here is actually an app. It's a packaged app. And I've got it no title bar. I've got it glued to the side of the screen. I've got it have no UI widgets, just full edge-to-edge control under my power end. And further, I even have it integrating with the OS in an interesting way. I put up a rich notification here showing how I'm doing this presentation on a Pixel. I hope you all enjoy that and can play with some of these things like I am here. The rich notifications that you can deliver there are a relatively recent API that we rolled out that mirror the kind of things, notifications that you're used to doing with Android. In fact, we're trying to make them parallel in most ways. So these apps are very capable. And what I mean by capable is that they can have access to the underlying operating system primitives. They can do things like access TCP/IP sockets. They can access your hardware. So for example, let me just pull up a couple here. Here's one that's built into Chrome OS, and it's like a simple camera app that's talking to your webcam. Notice it just looks and acts like a native application, does everything you would expect. Here's one that maybe the techie crowd would appreciate. Here is, as developers, this is an IRC app, a chat room application where developers hang out. This is the Blink chat room where the Blink developers all hang out and talk about the things that are going on there. In order to implement this, you have to use raw sockets, TCP/IP, to talk to it. Again, this just looks like a standalone native desktop app. That's because the runtime enables that. I've got another application here that I can't give you the full demo of, but because I left a memory card away. But this is the G+ Photos application that basically allows you to automatically upload photos that when you plug in a memory card or attach your camera. So you just attach it, you can curate it. This is part of the overall G+ Photos experience. So offline. So Chrome package apps are offline enabled by default. So what do I mean by offline first? Let's define terms. On one end, offline can mean I have no network at all. I am not connected to the internet. I'm on an airplane. I'm in the desert, whatever. But really, the more common case is I've got a really bad network. It's unreliable. It's slow. It's flaky. I think a few of you are experiencing that right now. Maybe even the servers are down. Maybe the internet, your net connection is fine, but the particular server you're talking to is timing out or having some trouble. Native apps don't really have a huge problem with this because all of their code is already down on the client and already running. So if they can't talk to their server, all it means is they couldn't get some of their data. They can recover, they can detect that. The web has had some weaknesses on this front where, because we mix code and data together in HTML, it means that if you have a network outage as code is coming down, well, you have half your page there and your page isn't functional. And that's why we have reload buttons in browsers, because how many times do you hit reload a day? Invariably, there are errors. You have to hit refresh or hit back to fix that. But your desktop app doesn't have a reload button. So we need to make these apps work offline by default. And the way we do that is by having the code down on the device ahead of time so that it's always there, always ready to go, and enforcing the separation between code and data. Let me give you a quick example of this. Here's an app called Google Keep. Maybe a few of you have already tried this out. Really nicely done packaged app. And what you can see here is that it's basically it's a panel. So again, it's immersive. It's sort of a nice size that you can put it off to the side. Here, it's just in this case, I've just got a simple to-do item here. You can have other notes and photos. But what I'm going to do is I'm going to play with fire here, and I'm going to tempt the demo gods, and I'm going to unplug the network. OK, what happens? So what you'll see here is that it'll say that, well, actually, I need to turn off the Wi-Fi, too, which is actually working, which shouldn't be. Let's turn off the Wi-Fi. OK. So now you see that the display changed. It immediately detected that. It says all notes are now saved offline. And so what I can do here is I can still, even though it's offline, I can mark something done. I can delete an item. I can add another item. And it's all fine. In fact, if I just then reconnect this up, it'll detect that, wake up again in a second, and it says saving. And it's all back up in the cloud automatically. And there's no errors. And all of this really comes for free as part of the package. When you write a Chrome packaged app, it's offline by default. It's also cloud-enabled by default. So it's all fine and good to be offline, but then you start to lose some of the advantages that you have with the web. Web is cloud-enabled by default, but not offline-enabled by default. Native apps tend to be offline enabled by default, but not cloud enabled by default. We're trying to have a bit of both. And the way we do that is by providing a number of useful APIs out of the box. One of them is one that we introduced last year called Chrome Storage Sync. And what that does is provide a way to have simple key value pairs stored reliably, synchronized to your account no matter what machine you're on. They follow you around, come with you. And that's really useful for things like settings, configuration, state. So imagine you set up your app on one machine, you go to another machine, now it's all set up, ready to go. Or that you're playing a game and you're on level 3, and then you go to another machine and that one is on level 3 now too. It's really useful for that sort of simple state data. But what if you need to deal with larger data? Well, recently we just announced another API called Chrome Sync File System. And the Sync File System API uses your Drive account to store documents, to store photos and media files and that sort of thing. It's really good at these large chunk document types. And again, automatically works. All you do is use the HTML5 file system API, create your files, save them into there, and you as a developer for both of these APIs, you didn't have to set up any cloud infrastructure on your own. You didn't have to set up your own servers. You didn't have to deal with scalability concerns if your app was a runaway success, because all the data is stored in the user's account, not your account, not on your server, so you don't have to worry about all of that. Now, there's a third type of data that the observant among you will notice I didn't talk about, which is database or transactional data. And that's where you're getting to more advanced use cases where it's really hard to have a generic API that addresses everybody's concerns. So you tend to have to write most of that logic yourself. However, we help you out a bit there too. Just last week, we announced Google Cloud. We announced a push messaging API, which is sort of the mirror to Google Cloud Messaging from Android, again in Chrome, and allows you to push data down to your device automatically. And the nice thing about this is the reason why this helps in that synchronization, that database transactional synchronization model is it means that again, your app doesn't need to your app can always stay up to sync in the background. Because what can happen is your server can say, okay, something new happened. A message gets sent into the push messaging, and Chrome will receive that, the Chrome runtime will receive that message, wake up your app, let it run code, let it download what it needs to do, and again, you can handle the synchronization logic yourself. Now, I mentioned earlier that, we're using this heavily for Chrome OS. It's more than just as a platform for third parties. We use it ourselves for a lot of the built-in apps. That camera app I showed you earlier, that's a packaged app that's built into Chrome OS. Even the file manager that we use to look at images and videos, yeah, that's a lovely picture, and movies inline, all of that is done as a packaged app. Calculator, that's all there too. All the little utilities and things that make an OS an OS are part of that. Chrome package apps are also cross-platform by default. Since you're building it with HTML, JavaScript, CSS, and it's built on top of the Chrome runtime, your apps run everywhere that the Chrome runtime runs. So for example, let's say that you're 500 pixels, and you wanted to write a desktop app version of your website. So you build a packaged app. Photos all sync offline. You can browse them, view them. I'm using touch here to control this and scroll around. But this app runs and works exactly the same on Windows, on Mac, on Chrome OS, on Linux. And when I say cross-platform, I also mean mobile. And this is something we've been working on since last year. But probably many of you haven't seen it yet. But let me give you a sneak preview of what it means to run a Chrome packaged app on my Android device. So here's that same 500 pixels app doing exactly what you'd expect it to do. Basically the same code, very little needed to be modified in order to bring that over. So how does that work? Well, what we did is we started contributing a year ago to the Cordova project. You may know it by its commercial name, which is PhoneGap. Cordova, what it does is it wraps up the native web view on a platform with around an executable and then runs the HTML, JavaScript, CSS in that local context. It also allows you to have native API bindings to it. And what we've been contributing, in addition to contributing to the overall quality of Cordova, performance and features and modularity and that sort of thing, we've contributed some modules that provide a compatibility layer for Chrome packaged apps. So basically, you can build your Chrome packaged app and now target Cordova and run your same app with the same APIs on iOS, on Android, and other Cordova projects. Thank you. Thought a few of you might like that. So, so speaking of development, let's just talk about development and what that means. Because it's HTML, JavaScript, CSS, you get access to all the same great developer tools that you've been seeing everybody use in all the talks around here. And if again, you've probably heard this before, But you know, if you haven't checked out the Chrome developer tools in a while, you should. They're changing at such a rapid rate, they're improving, and they're pretty amazing and powerful. So, so for example, here I can look at the full, you know, details of my app, this presentation app, inspect all of the elements. I can you know, turn off, toggle things, edit things. In fact, I noticed something embarrassing here. Somebody pointed this out to me, that maybe you know, 3 gears intermeshed together isn't actually the best example of productivity. So let me just fix that here, and just I'll just move that off to the side there. And so I think that's a better looking thing. Now not only that, but again, because it's web stuff, let me just run another package app here, which is a simple code editor that we've got up in our GitHub repository, text editor, that has, you know, full syntax highlighting and everything you'd expect there. And I'm going to find this slide here that I'm looking at right now, and you can see that it's very simple. It just has this one text here, but I'm going to make it just another little change, standard stuff. And because again, this is a, you know, because this is an app, just edit, reload, and away we go. So, so that's great. You can build it. It works just like like you'd expect with web technology. But now you want to get that app out there. For those of you who have been playing around with apps or extensions, you know that the way to do that is through the Chrome Web Store. Chrome Web Store is really easy to get going. What you do is you just package all your files up, all your source code up in a zip file. You upload it. You add a few, you know, assets so it can show up in the store properly. You hit publish. An hour later, it's live, and your users can, you know, start using it, installing it, and whatever. We've also been working on a number of improvements. Since last year, a number of you may have noticed that we made some pretty significant changes to the layout of the web store, and these have been mostly aimed at end users, at things like discoverability and things that keep users coming back to come looking for more, and it's succeeded on that front pretty significantly. So we now have you know, much higher install rates and return rates for users coming back, and we think that that's a big win for you. But we're not done there. What you're seeing here on this slide is just a sneak preview of a more structured layout, where we're going to, rather than just having this long continuous wall, we're going to have things grouped up into some sections so that people can sort of see the source where these things are coming from, and again, hopefully give them more ways to explore and find new items. We're also spending a lot of time working on your developer pain points, the things that you've told us are making your life harder to do within the web store. So for example, one of the main things we've heard is that it's kind of a pain to administer these things when you're within your company. And so we're adding group administrative features. So that means that you can have a Google group, have different members of that group, and then they all can access different aspects of the management of the app. So you can have your marketing person access it, edit the copy, your developer uploads the code, your business person looks at the numbers, and you don't have to worry about who comes and goes from your company and how to manage that. It's very simple. We're also working on things like incremental rollout, so that you can do experiments. If you've got a large number of users, maybe you don't want to you know, have a new update go out to all of your users all at the same time. So you can do a % rollout, see what the feedback looks like from your early users, and then scale it back if there's a problem that you discover. And finally, for the native client developers in the crowd, we're also working on making it so that the download size for end users is smaller, so that they only download the chunk of the CRX that they need in order to run their native client application. So that should be dramatic improvement in download speed and how long it takes for them to get up and running. So okay, you can get it published. Now you'd like to actually make money. I'm pretty sure that most of you are here because you would like your apps to be able to make money, right? And maybe there's some hobbyists, but really we want to figure out how to make this work. And aside from upfront purchase, which we've had in the web store from the beginning, we're also adding in-app purchase now. And I'll give you just a preview of what this looks like. Here I've got a kind of a contrived, I want to buy a gold star here, so I hover over this. When I click on it, it just pops up some Google Wallet API, UI. If I wasn't signed in, it would walk me through the sign-in process. Again, you as a developer don't need to write any of this code. But if somebody is already signed up, they just click, you know, the buy button, and it takes a second or two. And I'm going against a debug server, so it's a little slower. But now it's done, and boom, I've got a gold star. And if I hadn't done it, it would have given me a failure message there. Really simple to use. Just drop in a little line of JavaScript, and away you go. We're really interested in talking to you about some other things on the monetization front. We've got a number of other projects underway that we're not ready to talk about quite yet. But we really, this is an area that we're really going to be focusing on over the next 12 months. So basically, Chrome package apps are immersive. They've got rich OS capabilities. They're offline by default and cloud-enabled by default together, and that's an important combination. They are cross-platform. You write your app basically once. It'll run across these different platforms. You'll be able to share a large amount of the code as you go, even to mobile. And you get all the great development tools you're used to. My slide is a little crunched here, but distribution and monetization come into play there as well. So I'd like to walk you through now a few concrete use cases. So we've just talked about what Chrome packaged apps are, but now who should use them? Why would you use this over some other native desktop app technology? So one example is Chrome OS, and as you heard in the keynote, Chrome OS continues to grow rapidly. We're still early days, but the fact that we've been one of the top sellers, top laptop items in Amazon, we're doing extremely well and expanding our reach in retail, in Best Buy, and in international circles, as you've seen announcements that we're expanding the number of countries we cover. Now is a great time that you can step in and sort of be the app. If you go out into the Chrome sandbox, for example, you could see a video editing application. This is something people sort of said, well, you can't really do that on Chrome OS. Well, yes, you can. With Chrome packaged apps, you can do an offline capable full video editor. Or maybe you've got an idea for some diagramming software. Well, you can be the first one out there who builds that diagramming software, and like Glyphy is, and again, they're out in the sandbox, and now own that space. You become the diagramming software for Chrome OS by doing that. Now, I mentioned cross-platform before. This is an important use case as well, but I want to expound on it a little bit because it's the main thing that is changed over the last 10, 15 years on this front is it used to be that you really only had to write for one platform before. You used to have to write for Windows. But nowadays, you have to write for Windows, for Mac, for the web, for 2, 3, 4 mobile platforms maybe, and maybe even another version of Windows, Windows 8. You might need a different version of your app, right? And each of these different platforms that you're targeting has a cost to it. You have to have, there are different technologies. You often have to have different developer teams, different areas of expertise. Maybe you can't share the code. Maybe you can't keep the apps in sync. All of that is a cost. And there's also hidden costs that developers often forget about up front. There's things like installers and auto-updaters, all this sort of guts that sort of keep your app working and get it out to your users and help make it all work. Those are things that we take care of. You don't have to write an installer ever again. You don't have to write an auto-updater ever again. So another interesting use case is device apps. Now, what I mean by this is these days, there's a lot of interesting gadgets out there. There's fitness equipment, there's GPS-connected watches, there's things that use to sync music to my car. Basically, there's this resurgence in consumer electronics because these devices are all now getting internet connected, syncing data with my computer. And what that means is that each of these devices needs to be able to actually talk to my computer in some way. They need to have some bit of software that runs on the app. And if you're one of the developers that's writing one of these things, you now have a problem. And again, it's this cross-platform problem because you have to go where your users are. So you have to write an app, write maybe even a device driver, for each of these different platforms. Well, we provide some APIs out of the box that allow you to do USB, Bluetooth in a cross-platform way from userland code. And let me just show you a really simple example of this. This isn't, this is a little thermal label printer that you probably saw up, on a few of the people downstairs using. This is something where where I'm connecting this up to a Chrome OS device. Now, this device doesn't have a device driver. This OS doesn't have a device driver for this guy. It didn't know about it at all in advance. But we have a little sample app that we wrote here that is written specifically for this. And I'll just do this. And let me also just again integrate with the webcam, take a picture, and I say print. And the printer starts going and talking. And this was something that one of our developers banged out in an afternoon at one of our hackathons. So anyway, you can't really see it very well there, but again, all of that was done without the OS having to know about things in advance, installed from userland code. Really easy. Another interesting use case, if you're a developer, you've had to write a kiosk application, an application that needs to be full screen, locked down, single purpose. Think ATMs or airport ticket buying things or reservation showers, or even at the front desk here when you were registering this morning. This is a kiosk application. And traditionally, kiosk applications have been written on old versions of Windows XP. There's an industry there, and you've probably all laughed and seen the blue screens of death, on various terminals around as you walked. And I assure you, for the developers who write that, that's not funny. It turns out that not only is stability of the platform a problem, but also administration, pushing updates is a big problem for these things. And I'm happy to announce that today, we're rolling out kiosk app functionality in Chrome OS. This means that you can use our enterprise policies, our dashboard, to automatically push out and deploy a kiosk application to a Chrome OS device and have it boot up and be in that mode. And because it's Chrome OS, it will auto-update automatically. Your app will auto-update automatically. It's all written in HTML and JavaScript. It's much easier to build, debug, test. And in fact, as I mentioned, the kiosk app that we're using downstairs is using this technology. It's worked pretty well. I'll show you another one that one of our partners out in the sandbox is using. This is from Pearson. This is they're a test. They do tests, test taking. So this is a student test, so aiming at high school students or something. But they basically want to take students in, put them in front of a computer, have it be locked down, just take the test, get the result, and have things go, and it starts asking questions and all that. So right now, because I'm running this sort of already logged in, it's not really fully in kiosk mode, but you'll have to take my word for it about what that would look like and that the user wouldn't be able to pop out like this. Okay, games. Now, games is another important use case we've spent a fair amount of time looking at. This one takes a little while to start up, so I'll talk a little bit over it. So this is built using native client technology. What native client allows you to do is use native code and bring it to the web platform basically with the same level of security as JavaScript, but the similar performance to native code. And this one's built using the Unity engine. It's a cute little game that's in the web store now. This is a little demo here, which I apparently have reset recently. So anyway, you hop around and you've got multiple clones of yourself. It's very cute. I'd recommend trying it out here. I can't really demo it all the way, but you could see it had a few interesting features. It could be full screen. It could you can add things like mouse lock for first-person shooters or that sort of thing. Integrate with the gamepad. Again, do what you need to do as a game developer. Another interesting use case, again, something you can go out and see firsthand in the Chrome sandbox on the third floor, is this idea of saying, I've got a website, and I want to make that website even better. And it looks like I need to log in here. Uh-oh. Best laid plans here. Well, you'll have to go check it out, the sandbox. The idea here is that basically take a website and and give it extra powers. In this case, they made it something that was offline that could sync in the background, issues down, and so that no matter where you are, whether you have a network or not, you always have the latest content, and it's always on your device, ready to go. And it's a full-screen immersive experience that you can bookmark and share, and that it remembers where you were and picks up where you left off when you go from machine to machine. So a bunch of interesting use cases. These are where we've been getting a lot of the most interest, but we think there's more out there. These are just a few of the key examples. So let me talk a little bit about where we're going. So I mentioned we're in consumer preview now for Windows and Chrome OS. That's in Chrome 28. If you're on the dev channel, you can go to the web store, download, play with some of the apps that some of these developers have been making. We're going to do our full consumer launch to Windows and Chrome OS users in Chrome 29. That's later this summer. Mac and Linux support will be coming soon. Right now, you can run it and test it, but we don't have the full OS integration for Mac and Linux done quite yet. That'll probably be in the 29 timeframe as well. We're continuing to work really hard on Android and iOS. It's pretty early on, even though the demo I showed you looked pretty good. We're not quite at the stage where we think every developer should go rushing and give it a try. But we're going to start reaching out to early testers soon. And we'll be talking at the Cordova conference in July, and we think we'll be ready for wider use around that time frame. So another interesting use case I didn't talk about because it's something we're still working on and looking to do is we want to make it possible for people to build developer tools on this platform. And you saw a few examples. Yes, I wanted to. So one of the big things that we've heard from Chrome OS users is that they love the machines, but they would love to be able to do self-hosted development just on this machine. As developers, we want to be able to use the computers for everything, right? And because of the model that we've got where apps tend to be sandboxed themselves, that means that we have to figure out how to make the apps be able to share and communicate with each other as developer tools often need to do. So we're working on some experimental new APIs. You can look in our GitHub repository for a sample app that we're building that's sort of an IDE for Chrome OS. Monetization, I mentioned this before. We've got a lot of ideas on new things we're going to do on the monetization front, new APIs. These are both areas where you could get involved with the community and give us your feedback about what you think are our highest priorities for you, the things that you most need. And of course, we're going to continue to work on those core concepts that Linus mentioned, the keynote, speed, simplicity, security, polishing the platform, making it faster, making it more reliable and more secure. So thanks everybody for coming. I just want to give you a few more pointers to information where you can learn more. We have a number of talks going on about packaged apps. Joe Marini is doing a talk on Thursday, I believe, about how to convert your website into a Chrome packaged app. We're doing a code lab that Renato over here is going to actually allow you to create a packaged app from start to finish. The guys behind the G+ Photos app that I just gave you a brief demo of are going to give you a walkthrough of what it took them to build a large, full-scale Chrome packaged app with real database synchronization to the cloud. And you can always find us up in the sandbox. There's a bunch of app developers up there that have built cool things with this technology already, and you can learn from them about what they like and what they don't like so far. Of course, our documentation, you can find us on G+. We've got a great community there. Stack Overflow, we're there answering questions. We've got a mailing list. And even the developers are hanging out on our IRC channel if you want to come talk to devs directly. So thanks much, and I'll take questions now.
Hello, this sounds really cool for developers, but I was wondering if you could talk a little bit about the user experience. You mentioned Google Wallet and Google Drive account and a Google account and all those things. And I know that, for example, in Germany, there's a lot of people who are reluctant to giving all of their data to Google. And I was just wondering, how many things do I need to install as a user? How many things do I need to sign up for? And how many accounts do I need to merge into one? And how much data am I giving to Google and sharing everywhere to be able to use these apps?
So, I mean, it depends on the apps. The apps don't have to be tied to Google in particular, but some will be, just like some apps are tied to other platforms. And so it's up to the developer about what they want to do. We do require that you have a Google account to sign in so that we can take advantage of some of the functionality with sync and sync file system and that sort of thing, so that we don't force you to go through that sign-up process when you install the app within each app. We try to handle it in a central way. But really, it's up to the app about how much they want to do on that front.
How about the installation process for the software?
Right, so the installation, so at that point, the only thing you need to do is, we handle that for you. If you've got Chrome, it'll just install automatically. We're also working on ways to have it so even from other browsers, you'll be able to just install these apps as one step.
Okay, thanks.
We're currently using packaged apps with WebRTC on like Mac OS, and it works great. So when you port it over to Android or to iOS, is WebRTC going to follow with you? And then also, if you just talked about the messaging components as well. So does it, when you take it into Android, does it change the Chrome messaging into Android cloud messaging, and how does that all work?
Sure. So those are all great questions. As I mentioned, we're pretty early on with the Cordova stuff, and but it's important for people to know there are a few limitations of the Cordova stuff. One is that we're dependent on the web view on the platform that we're on with this. So if the platform doesn't, like iOS currently doesn't have WebRTC, it'll mean that, that we won't have it WebRTC there. Now we're going to try to have polyfills when possible on some of the features, but some of them are so in depth to the
because Android has WebRTC now.
What's that?
Android has WebRTC now.
Yes, so Android has WebRTC now, so you would have access to it there, but iOS doesn't, for example.
Right.
And so, but for the Chrome APIs in specific, those are all things that we provide bindings for, and we'll provide bindings and try to map them.
So basically, if it's in Chrome on the operating system, you'll support it in the packaged app.
So if it's in the web view, if it's in Chrome, the Chrome.star APIs,
right,
we'll try to support it as best we can and map it to the native equivalent. So if it's rich notifications, we'll map the notifications to whatever the system can do there, that sort of thing. And when it's part of the web platform, we're limited to what the web view can do on that platform.
So now, as far as the messaging components go, if I use Chrome messaging and you're in Android, will it move the message to Android?
That's the idea, although we don't have that one together yet.
Got it. Okay, thank you very much.
No problem.
Hi, I'm actually an Android developer and student who got interested in packaged apps when his MacBook broke down in the middle of the summer and spent the semester using a Chromebook. I know you mentioned an IDE for Chrome extensions in Chrome OS, but have you guys thought or talked at all to the Android or other development teams about making tools for other platforms for Chrome OS?
Oh, I see. So you want to target Android? Yes. So in fact, one of our internal guys has a prototype version of ADB working on a Chromebook that's building using our socket and USB APIs.
Okay.
And so yeah, it's definitely possible and something we're interested in. Some of it's going to be harder than others. You know, for example, bringing Java over to Chrome OS is a little more work, obviously, but we think that with a combination of native client and web technologies that we can get pretty far.
Okay, and one other question is, I know that it can compile to JavaScript, but how does Dart play into the Chrome packaged apps? I know it's made more for application development.
It'll be the same as the Chrome runtime anywhere. So you could either today compile it down to JavaScript, and we've got that working. We've got a few examples even up in our GitHub repo. I didn't have a link to that there, but definitely check out the GitHub Chrome examples. But when a Dart VM becomes integrated in the Chrome runtime, if that, assuming that happens, then we'll just get that for free, and we'll have Dart bindings for all of our APIs as well.
Cool. Thank you very much.
Yep.
Yeah, I want to ask you about the uploading process for the web store for the Chrome packaged apps. And actually, I am very interested in Socket API. And I heard that in the Firefox OS cases, using TCP socket or UDP socket, they also check the such packaged apps in the detailed way by the human. So, but I want to ask you that such a human check process will be applied for such a, for example, Socket API is using in the package apps.
So I think we should follow up afterwards because I didn't catch all of it, but all of your question. But it sounded like you were asking when human review process kicks in versus automated review process. And for the apps APIs in general, no, it's all automated. It's really, we only have human manual review for extensions that use NPAPI today.
Okay, hi. I'm come from China, Zhuhai GDG organization. So I noticed the Chromebooks for the Chinese only one IME. So my question is, the IME can can make as a package app. So I can customize my special IME.
With the extension API, you're saying?
IME import.
Yes. Yes. So I mean, we have an extension API for making your own IMEs, and so that's documented in the extensions system right now. I'm not an expert in that particular one, but there's probably some folks up in. We could probably, if you come up to the Chrome sandbox area, we could probably find somebody who can help you out.
Okay.
Yep. Yep.
So packaged apps seems to have tons of additional useful APIs. Is the goal for these APIs to become web standards?
So it's a great question. It's something that we've been talking to other browser vendors about and other people who are working in this space, and we think we're actually really excited about the possibility of standardizing these. Right now, we think it's a little bit early. We've been interacting a little bit with the other folks and sort of toying with some of the ideas of like what could happen, and we actually were part of forming the SysApps working group to see if that made sense. It's like I said, it's still kind of early on right now because each vendor is working towards their own shipping product yet, and we don't have any forcing function that would really require interoperability to happen. And I think that's where standards come from, not by things we design in committees up front and try to get everybody to follow, but really when you have multiple implementations that want to find a way to interoperate. And so first we have to everybody ship and what they're working on, and then we'll figure out how to start pushing on the interoperability thing. But we're very interested in that and continuing to talk to the other vendors about it on a regular basis.
And when you say we are waiting for everybody to ship their own version of packaged apps, are you including the Windows 8 programming platform?
So that's already, yeah, exactly.
Which
Windows 8 has
also
essentially already shipped, and Boot to Gecko is close to shipping, and Tizen is close to shipping their stuff, and there's a number of others that are out there, and so we're just sort of waiting for the forcing functions to come that'll drive us towards standardization.
Okay, thank you.
It looks like we're out of overtime, so I'll stick around afterwards to answer a few more questions, and then I'll go up to the Chrome sandbox area, and happy to take more questions from folks there. So thanks much, everybody.